there's been a lot of talk when talking about LLMs, how they can be used to assist professionals as a co-pilot. We see this. Maybe the first application is going to be software developers getting help while you write code. That's going to be immensely useful. It's probably going to help write higher quality code. And why shouldn't that be the case for doctors and healthcare professionals as well? I was thinking if you follow the path that we've talked already, like first you can have a transcript, and then eventually maybe the transcript can be reasoned about by artificial intelligence model in real time. It should be possible for the model to act as a co-pilot for the doctor. Something like tapping into the vast knowledge base of the medical field in real time while talking to the patient. Obviously, that is kind of the function of a doctor to do, but if you can have help by a machine that has instant access to all the information that exists, it should be much more powerful. I'm thinking, for example, in a consultation situation where the work is to diagnose a condition based on the observer, what the various things that you observe on the patient. The doctor will usually narrow it down to 1, 2, or maybe 3 different possibilities quite quickly. But then I think it's a common mistake to not think about the more rare conditions. This is where I think an artificial intelligence can be extremely useful, is to consider in an objective fashion, given the input in a consultation, all the different possibilities, and help the doctor finding out what questions to ask and what examinations to do to provide a differential diagnosis, as it's called, to differentiate between the different possibilities, taking all the actual possibilities into account, not just the ones that sprung to mind for the doctor right there, which is prone to be the most common ones. What do you think? Do you think this is feasible?
Well, this is a very exciting possibility, and it's even more exciting that I think it is definitely feasible. Within a year or two, you're going to be seeing these kinds of technologies hitting the scene. So the way that we think about this problem currently is in terms of a multi-model pipeline would support this kind of technology right now. So we have like the pieces to be able to do this. As you mentioned, we have the transcription that's like sufficiently accurate and able to run in real time. Now we have the second piece that we need, the large language model that can take the result of a transcription as it's coming out and can understand. So we think of the transcription as the perception layer. We think of the LLM as the understanding layer, and then also the generation layer. So it will perceive, understand, and then generate. That's kind of the paradigm that we think about here. And these kinds of systems right now are going to be built in a couple of different components. So we have the ASR system, we have the LLM, which in real time would be taking in the transcription of the conversation between doctor and patient, understanding that, and then taking actions. You could train them specifically to take actions. And in this scenario of a co-pilot, the LLM would be trained to look things up in a knowledge base or trigger a system that would look things up in a knowledge base. And as you mentioned, one of the limitations that we have as humans is like very similar to machine learning models, we're biased by our training data. So like we have, based on our experiences and knowledge in the world, like specific things that we will key in on. Like for a doctor, they'll probably have a very strong distillation process where they'll immediately think of a couple of most likely
And it happens very naturally. If you're a general practitioner, for example, 90% of the cases you get will be the same 5 to 10 different conditions. So you naturally gravitate towards them, and at some point stop considering all the rare ones.
Totally, that's right. And so this is one of the really interesting capabilities that an AI system would give you, as you said, the ability to consider like all possible solutions to the problem, but diagnoses, even the rare ones, and be able to spot patterns that a human would not be able to spot. So this is the other, one of the other reasons why AI works so well and can do things that humans cannot necessarily do. So that they do basically very, very complex pattern matching. And so, in this scenario of a copilot, I think that the tools are basically there. The components of this system are there, and people will start to build this kind of system that can provide value to doctors in real time. Now, one of the challenges there, though, is the real-time aspect of this. So that will be like probably the biggest one of the bigger technical challenges that people will have to solve in the near term.
Right, because currently this wouldn't be it wouldn't be feasible with current technology, just because it would take too long time to process to get the results.
Yep, that's right. So.
So basically, the doctor would get the data from the AI, but it would happen after the consultation, not during it.
That's exactly right. So one thing that you notice when you use real-time transcription systems is that if the latency is, say, like 500 milliseconds or more, humans can detect the delay immediately. So you have to have latency below a certain level. So it's actually a very, very small time scale. So your technology has to be very fast, able to deliver results within 500 milliseconds, and then you won't be able to perceive the delay. When the delay gets to seconds, a co-pilot system that's supposed to be operating in real time is no longer operating in real time. It's lagging, and it would be very difficult to interact with the technology in that scenario. And so you need your real-time system to be giving you back results almost immediately. And in order for that to be true, every component of the pipeline has to be blazingly fast.
Right.
And right now, the biggest bottleneck, actually, depending on which ASR carrier you're using, the transcription could be a bottleneck. DeepGram is very, very fast, so we have like nearly instantaneous real-time transcription. And then the LLM is the other thing you have to address. You need to make that fast. In order to make that fast, you can't be using an LLM. You have to be using an SLM. A much smaller language model that's.
Okay, so it's an SLM is a small language model as opposed to a large language model.
Yep, that's right. I think we need to change the conversation around LLMs, and we need to be talking about SLMs.
Okay,
that's really what people want to need.
And they're just faster, smaller, and faster and more nimble. Is that the pro?
Yep, that's the idea, and fit for a particular purpose. So, these SLMs, you would not be using them to write an email or to write a play or to write poetry or something like this. They'd be doing perception and understanding of a doctor-patient interaction, and they'd be doing a lookup into a knowledge base. They'd be trained specifically for these tasks, and therefore, like, you could use a significantly smaller model to do this. You don't need the same amount of capacity that you get with an LLM.
Is this something you're working on, or who would be the type of? I guess if the large tech companies are focused on going in the general artificial intelligence direction, who would be the actors that would be the natural ones to focus on these SLMs?
I would say any company that is trying to solve real business problems for particular use cases at scale should be working on SLMs, and DeepGram is one of those companies. So yeah, for sure.
That's awesome. That's awesome.
Yeah.
Cool. Yeah. So I actually had this idea that I was kind of envisioning I've seen so many of these telehealth consultation situations where the doctor is talking to the patient. So the kind of system that I'm envisioning is an artificial intelligence thing is listening to the consultation, deriving meaning out of the consultation, and kind of annotating on the screen while the patient and the doctor is talking. For example, providing a list of potential diagnoses, and then the doctor can interact with them to bring up what are the typical questions that they need to ask to differentiate between this and the other diagnosis, for example. This should be doable within a few years then.
Oh yes, I think so. I think maybe even within 1 year.
Okay, that's awesome.
It's a fairly aggressive timeline, but it's possible. Yeah, yeah, it's possible. 1 to 2 years, I think these kinds of systems will be coming out. Yep.
Fantastic, but it would be fairly specialized. Like you probably have one such system for general practice, and one for pediatry, and one for geriatry, and the different specialties within healthcare has many peculiarities. So you probably need to have different systems for each area.
Yep, I agree. This is something that DeepGram has been tackling, this kind of customization problem, since it's like early on when the company was founded. So we do custom models for transcription. We have found that only in the domain of transcription, but this applies to other kinds of problems as well, including the problem we're talking about, is that customers in different industries, and then in sub specialities within a particular industry, will have specialized aspects in their data that are not easily modeled or accurately modeled by a general model that's been trained on a broad swath of data. So the way people always start building models in machine learning is they build general models first, because models need to see lots of data to become highly accurate. This is like one of the limitations of machine learning, generally speaking. So you build a general model first, and then you specialize it to do smaller scale tasks and to work on particular kinds of data. So you can imagine taking a general transcription model that's been trained across all kinds of different domains, then you specialize it to phone calls or meetings, and then you specialize it to telehealth consultations by training only on that kind of data. And there's a number of reasons why you want to do that. The vocabulary that's involved in those kinds of interactions has a lot of specialized terms in it. So you allow the model to learn those terms in this specialization training. And then it also adapts to the particular audio conditions. And so we found that this general to highly specialized paradigm is very important. Lots of businesses need that. So we've been training what are called custom ASR models for particular customers, where we start with our general model that's been trained on a very large amount of data. We specialize it to a use case model, and then we take that use case model and train it on very, very small amounts of data from the customer to produce the custom ASR model that they would then deploy specifically for them. The same paradigm will apply in these Copilot systems. When you're just going to be specializing each component of the model in the same way.
Yeah.
Yep, I agree.
That is awesome. So we're moving towards that, but I have another subject that I just wanted to touch lightly on, and that is language. So I've been impressed myself with ChatGPT and its ability to communicate in different languages. Even my own native language, which happens to be Norwegian, which is a very small language, and we are here in Norway. We are not used to being spoiled with technology that can speak our language. But ChatGPT can communicate perfectly with me in Norwegian. And that is really, really impressive. So it makes me think that language, which still is a problem in healthcare, it should really not be a problem anymore. It should be possible to have technology that can easily translate in the communication between a doctor and a patient, where the common situation is that the doctor speaks one language and the patient speaks natively a different language. And even though they can speak some of the doctor's language, most of the time they want to have an interpreter, because it's really important to get it right. Like, these are not casual interactions. It's an important conversation. So ideally, the technology should be able to solve this for us. We should get maybe closed captions or some kind of translation of what's being said into our own language.
Totally agree. The trajectory of machine translation is kind of like similar to summarization in the sense that the models were not very good for a long time, and then over time, very large public data sets to do machine translation became available, and you had models that were better, like a Facebook model called M2M100 that can translate between hundreds of different languages. But for many of those language pairs, the quality is not great. If you ask native speakers of that language or of both of those pairs of languages. And so even the best machine translation models up until the last couple of years were not great. And so the ability to do a real-time translation in a telehealth scenario or other kind of patient-doctor interaction, that was a hard problem that I would say was probably unsolved up to this point, not well solved. Well, now with LLMs, they have changed the game for translation. It's very similar to summarization in the sense that, like, they were not trained specifically to do machine translation, and yet they can. It's incredible just by having seen, text in many different languages from the internet, and the fact that, like, the model forms an internal representation of the semantic content of what's being said that's sort of independent of language, and is then able to transform that and then export it out into a particular writing system effectively is incredible. It's one of the capabilities that's kind of like the magic of LLMs. And so this opens up a number of possibilities, like you're saying, to be able to leverage this for real-time translation. You still have the same limitations that you had when we were talking about our real-time Copilot system.
Yeah.
Your translation model, which may now be built around an LLM, needs to be fast. And so, like, we're still going to have our SLM paradigm probably coming in here, where you start with an LLM that can do translation and you distill it down to an SLM, and maybe you specialize it to only be able to translate particular language pairs, and maybe that's an initial entry point into the real-time problem. So you don't have an SLM that can do any pair of languages like the LLMs can currently do, which is incredible. But they'll be specialized to do particular pairs of languages. Yeah. So I think this is another thing that we can expect to see in the next year or two.
Yeah.
It's going to be like a game-changing technology.
And then there's probably, thinking about it, there's probably, like, you when you translate from one language to another, you kind of need to hear a little bit of the context before you can properly translate. So it's never going to be a translation like that. Is never going to be completely real time. It has to listen to the full sentence sort of before it can translate, because maybe the ordering of the words is completely different in the other language.
I agree. That's right. Totally agree.
So something like seeing seeing a closed caption with the full sentence, like maybe 5 seconds after it, something like that. But I think still that would be tremendous help in healthcare.
Yep. I fully agree. I think that real-time translation is definitely a hard and unique problem. Maybe you would have a system that has an initial lag, where it like as you said, it needs to listen to the first several seconds of a conversation. But then you'll have systems that once it has built up enough context, will be able to like have a window of past context that kind of slides along with the conversation, with the model, and the model will be able to look in that past context. It'll have a memory of what's been said. And so you may actually only suffer in terms of accuracy or delay in the very initial part of a conversation until you can build up that sufficient amount of context. And then maybe perhaps it can be near real time after that, because the model will have some memory mechanism.
Yeah, it can kind of guess the meaning out of the context, more or less.
Yep.
Interesting. Well, this has been a really interesting conversation.
Very exciting conversation to have.
Thank you so much for joining us, and looking forward to collaborate further with you at DeepGram. And to our audience, we will continue with this recording, so stay tuned.